6-1, finish those.
I think this is where we left off, right, guys? A to the n times b to the n, or a to the n times a to the n, something like that. Yes. All right, so your guided note should be out from last night.
Yeah, just the exponent rule with the fractions, and then I think they have the negative exponent, and then shortcut flip it before you do it.
Well, we didn't get to this one, did we? All right. There's a couple ways to do this one. What do we do if we have we see a negative exponent? Logan. It's got to move, right? Now, what has the negative exponent? The whole thing inside the parentheses. So the whole thing would need to move. Okay? So typically, I take care of the negative exponents before I start simplifying. There's always exceptions to those rules. We might see other situations where it might be easier to not move it first. All right, so I'm going to keep the x squared times y cubed all to the fourth up top. There's no denominator, so we have to create one. And now we raise this to the positive fourth. Now, what rule did we learn yesterday? If we have a product of two terms raised to an exponent outside, what's the rule? I don't really want to write out x squared y cubed multiplied out 4 times, do you? Do you want to multiply x squared y cubed times x squared y cubed times x squared y cubed times x squared y cubed? I don't really want to. Can. Yeah.
Is it just distributing the 4?
Kind of, yeah. It's x squared to the fourth. It's x squared to the fourth times y cubed to the fourth. Do you guys remember that one? I need you to be honest with me here. Do you remember that? Okay. For those that need to see it written out, x squared y cubed, x squared y cubed, x squared y cubed, x squared y cubed. What's x squared times x squared times x squared times x squared? X to the... Whoa. Okay. Here's what we have to be on common ground with. Okay? You have to understand what an exponent is. What's x times x? No. You guys cannot make that error. That's x plus x. What's x plus x? What's x plus x?
2.
It's 2?
2x.
2x. Okay. There we go. What's x times x?
1x. Okay, x first.
What's 5 times 5?
25.
How's x times x x? If 5, you would say 5 times 5 is 5 then. Using your rule, what's 5 times 5?
25.
It's 5 squared, right? And what's 5 squared? 25. I was able to simplify because it's a number. What's x times x?
X squared.
X squared. Addition. Multiplication. Does that make any sense at all?
Yes.
All right. What's x squared cubed? Don't start guessing. It's now I'm going to use the rule in a minute, but for now, because you guys are you need this right now. It's x squared times x squared times x squared. Do you recognize it now? Let's try, and maybe we need to go further. What do you think? X to the 6th. For those who had no idea, what's x squared? Isn't it x times x? Times x times x? Times x times x. That's repeated multiplication of x 6 times. X to the 6th. Does that make any sense at all? You don't want to do that. You don't want to do this every time. Okay? X squared to the 3rd power. Power raised to a power. You multiply the exponents. X to the 6th. Do you agree? Back to the story. What's x squared to the 4th power? X to the 8th. It's x squared times x squared times x squared times x squared. X times x times x times x. 8 times x to the 8th. What's y to the 3rd to the 4th power? Y to the 3rd times y to the 3rd times y to the 3rd times y to the 3rd. Y times y times y. 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 That's y to the 12. We just did the numerator. Now let's do the denominator. How can I write x squared y to the 4th all raised to the 4th power, Braden? X squared to the 4th times
Y 4 to the 4th.
Good. Power to a power, you multiply the exponents. I get x to the 8th and y to the 16th.
That's an in-depth problem.
Thank you.
You got your every haircut last night.
I got them all cut. Thank you. What's x to the 8th divided by x to the 8th? 1. What's y to the 12th over y to the 16th? Now, before you answer, Mr. Parker went over this yesterday. Okay? He explained it the same way I would have explained it. I call it a little game. It's the world's most boring game. Okay? But I call it who wins and by how much. Same thing he said. Who wins? Who has more? Y to the 12th or y to the 16th? And by how much? So y to the 4th. What's our placeholder up top? 1. 1 over y to the 4th. Are there any negative exponents we need to take care of? No. That's it. Are you guys good? All right. Now, what if we are handed a fraction raised to an exponent? We're going to make a little shortcut out of this too. Okay? 2/3 to the 3rd power. What's another way to explain that to someone who's first learning exponents? 2/3 to the 3rd power is thought of as 2/3 times 2/3 times. This is the long way. 2/3 times 2/3 times 2/3. What's the numerator? No, what's 2 times 2 times 2?
8.
8. What's 3 times 3 times 3? 27. This is our answer, but we're going to write it a different way. Now, this is how I would want you to write it. But we're going to do this again. We're going to use a shortcut. 2/3 times 2/3 times 2/3. Isn't it? What's 2 times 2 times 2? What's another way to write that? Not 8, but 2 to the third power. Yes? 3 times 3 times 3 could be rewritten as 3 to the third power. Oh, okay. So if I have a fraction to an exponent, isn't that raising the numerator to that power and the denominator to that power? That could have saved us some time, right? 2 to the third is 8. 3 to the third is 27. Make sense? Do not forget, exponents are repeated multiplication. Let's do this one. How could I rewrite x over 5 to the third power? Who can raise their hand and tell me? Let's go with some different people here. Ethan, what do you think? X over 5 raised to the third power. That's x to the...
X to 3.
Yep. Over
5. This is.
Yeah, and because one of them's a number, we could rewrite it in another form, right? X to the third, can that be rewritten anyway? Or is that good? Yeah. It's good how it is. What's 5 to the third power? What'd you get, Ethan?
125.
Good. That's our final answer for that one. So a fraction to an exponent is the numerator to that exponent over the denominator to that exponent. All right, try this one on your own. Everybody's calculator should be out at this point. Don't you? Yeah, I'll do another one too. Samar, what'd you get? 16 over 49. Very good. Now, could you have written out 4/7 times 4/7 and gotten the same thing? Yeah. But this exponent rule will help us, especially when we're dealing with variables. Ooh, now we got a combo of rules. Combo. You guys want to try this one? Try it. Write lightly in pencil. Try it lightly in pencil.
Not like meaning. I know you're a lefty.
Remember how many lefties we had in the 6th period last year?
Well, there's a lot here. Did you just throw up? What's up? You okay? Leah?
She's a leftist.
No, she's a rightist. Doesn't like leftists.
You bring up a good point.
Left-handed
Which
people.
one is it?
What? A rightist. Right-handed people have issues with left-handed people. I don't know why. I think they're jealous.
Why would I be
Because we're
jealous
not-
of getting
because
stuff
we're
all
not-
over your hands?
They just know they feel left out.
No, we're in our right mind.
No.
Yeah, I said it.
That's a pretty good one.
That was a good one.
You can read it on here too.
That was a good one.
Oh,
Yeah, we're so joking with it.
Apple's designing a new automatic car, but they're having trouble installing Windows. Apple.
It's so dumb.
Apple
Okay.
is designing a new automatic car,
Okay.
but they're having trouble installing Windows.
See, Windows was.
Windows is a
Microsoft.
Oh, okay.
Explain it, Makana doesn't understand.
Yeah, I do. What does it mean for that? The windows are on like our school, like the Microsoft computers.
Oh,
The Windows are in a car.
Actually, our computer's Dell.
Dell.
It doesn't matter if
Dell
it's
can be
Dell
whatever.
or
Dell's like
Inspiron or whatever. It's like it's an operating system.
yeah.
Just like I could have a Samsung phone, but it has an Android operating device. Or I could have a Google phone, Android. I can have a Nokia Android operating system.
Do you have a Kia car and phone? Nice.
Yeah.
I had no.
Oh,
No, I was saying I had no ideas. I was idea.
All right, who can walk me through this? Aaliyah, raise your hand. Help me out.
I don't know. I was stretching.
Everything gets.
I said 3,
Oh.
4, and then D6.
Wow.
Over E4.
This isn't bingo. What? 3.
She's talking gibberish.
3. Do you mean 3 to the 4th?
Yeah,
Because 3, 4 is different.
yeah.
3 to the 4th?
And then D to 6.
Careful with that. Careful with that. D to the what?
D to the,
When you
yeah.
raise the power by.
All right, here's what we're gonna do.
Yeah.
We're gonna break it down step by step.
Step by step.
Sorry, guys.
All right, what's the rule we just learned? Okay, this is like an onion. You have to peel away the layers of it, and it might make some of you cry. All right,
I'm crying right
I'll
now.
start crying. Give me like 5 seconds.
Braden.
2 times 4. You have to do that first.
What?
See, I did
Alright.
2 times 4.
Do you agree this is a fraction raised to a power? We have to raise the numerator to the power over the denominator to the power.
Makana, leave Braden alone. Zip it.
Do you agree? Some of you may have skipped steps. This is the outermost layer of that onion.
Hey, you were in the movie The Natural. I liked you in that movie.
I don't understand.
He's
Did you
just
see the
pretty
movie The
supernatural.
Natural? Okay, then you wouldn't understand.
Yes, Braden.
Why wouldn't you do 2 times 4 if we did it up into the...
He's going to.
We're going to. We're not there yet.
He simplified.
Well, is it okay that I skipped a step?
We'll see if you cry. All right, when we have a biggest layer, we have a fraction, the whole thing's raised to an exponent. Numerator to the exponent, denominator to the exponent. Are you with me? Next layer, we have a product to an exponent. Ignore the denominator for now. We have a product to an exponent. We learned a rule for that. Isn't it each term raised to the exponent? Yes? Let's do the same in the denominator. There's still more meat left on this bone. What's 3 to the 4th? 3 times 3 times 3 times 3, or the calculator says 81. What's d squared to the 4th power? I hear d to the 8th. I heard someone
D to 6.
say d to the 6th.
What's the rule when you raise a power to a power? We don't add with what?
That's d squared times d squared times d squared times d squared. How many d's are there? 8. D to the 8th. D to the 8th over e to the 4th, f to the 4th. Can that be simplified at all? No. You got it right?
Yeah, but I erased it because Birdie looked at me weird.
What?
That's just his natural face.
Oh, now what?
You just got bird face.
See how it is?
Please ask if you're confused.
I'm always confused.
I'm confused.
On where?
Like, why didn't we just
Just don't like
like? Why isn't the answer just like 3D8, 3D power of 8?
Isn't 3D squared raised to the fourth power 4 factors of 3D squared?
Wait, what'd you just say? Hold on. Say it again.
It's in parentheses.
English, please.
If you raise that to the fourth power, that 4 tells me to multiply 3 times d squared 4 times.
Okay.
Right?
Yeah.
I just did it. Yes?
Yeah.
Isn't it? What's 3 times 3 times 3 times 3?
But didn't you say that we had to do the 2 times 4 to get rid of that? Because you said up here that for E for the power of property.
Are you down here now?
No, I'm up there. So
He's talking about multiplying the 2 and the 4.
We did. The 2 times 4 is 8.
Yeah, he doesn't get it.
why didn't we just
You did correct.
Did you multiply 3 times 4?
no?
Please ask it in a different way then.
Never mind.
No, go ahead.
No,
English,
I don't even
please.
know what I'm talking about. Never mind.
He's confusing.
I know there's other people who have questions.
You know,
Matthew.
So like for B or for 3D2, are you supposed to like separate them first, like from the 3 and D power 2? Are you supposed to do that since they're not common or like that?
You need to think of them as separate terms.
All right, got it.
Yeah, because you can't. Did you just raise d squared to the fourth power and kept the 3 there?
Yeah, I thought we need to do
I
that.
can understand why you did that. Okay, but the rule we learned was a times m. It was something like this. To the n is what? A to the n times m to the n. So if this thing's anything other than 1, you're going to have to raise both terms to that power. Even if it's a number. 3 to the 4th, 81. D squared to the 4th, d to the 8th.
Got it.
Mr. Parker, did you have something to add? Subtract?
Multiply. Right.
yeah, I think Braden just has to see that there's 2 terms up there. The 3 and the d squared,
Maybe we'll do
all
another
being
one like it.
raised to the 4th.
Try this one.
So,
This time, go.
um,
Do not skip steps. All right, let's check so we don't get too far ahead of ourselves. We have a product to a power. Did you raise each term to that power? 2 squared is? It's going to be 4. X cubed squared is going to be x to the 6. Everybody good with the numerator? That's like what we just did. That one should be pretty solid. Mary.
What I did is I did like 2 to the third in parentheses to.
Wait, where are you getting 2 to the third?
Because there's a 3.
But is 2 being raised to the third, or is x being raised to the third? Because Mary, it's not this. If it's like that, then you would be correct. But do you agree that 2 is not being raised to the third? Okay. I'm glad we caught that now. How about the denominator? Do you agree we need to raise the whole denominator to that second power? You guys okay with that?
Yes.
What is xy to the third to the second? Remember, a power to a power we multiply. That's a 6. Let's bring it on down here. Let's do the numerator. 2 squared is 4x to the 6th is good as it. It's good as it is. What's xy to the 6th? It's x to the 6th times y to the 6th. Can that be reduced at all? Are there any? We have all multiplication, top and bottom, right? Can anything be canceled? Matthew.
The x power 6.
What is x to the 6th over x to the 6th? 1. What's 4 times 1? 4. What's 1 times y to the 6th? That is your final, simplified, happy answer. Tricky. Alexis.
I did it like a different way, but I still got the right.
How did you do it, Alexis?
I put so I did 2 to the second power, and then in parentheses, x to the third power to the second power.
Yep.
And then on the bottom, I put x to the third power to the second power in parentheses by itself, and then do it to the y. And I just saw.
That's fine. Yep. You were very careful as you did that.
You really broke down. That's good.
All right, now to a negative power. Why do I have to do so negative? Mr. Parker, you want this?
I get to do it now.
Not ready for this.
Y'all ready for this?
I'm ready for that.
I saw somebody fumbles last weekend because they just weren't letting it just.
Yeah, they're grabbing at it.
Yeah.
Right. Okay, guys.
Amateurs.
I want you to, we're going to show you a shortcut. Don't write this down. If I'm going to, does everybody agree we don't want to work with negative exponents? This is a pain, right? Watch. If I would carry out this rule, this is what I would do. Right? Everything gets raised to the negative n. Right? That's all I did. And then, don't you guys agree? How do I make the n happy? Wouldn't I switch spots with everything? So wouldn't it be this? Whoa, come on. Come on. Wouldn't it be that? I'd just have to switch spots, then the ends would be positive?
Yeah.
Okay. We're going to skip a step. This thing's flipping out.
It doesn't like it. Only hates
It's on crack.
All right, watch. Here's what we're going to do. to get rid of the negative exponent before I distribute it, what I'm going to do is inside the bracket, I'm going to flip my fraction. And then when I do that, I can take my negative n and make it a positive n. Okay? So we're not going to deal with the negative exponents. And then everything gets to the n power, right? And then you can see we ended up with the same answer, but I didn't deal with the negative n exponent. So that's our shortcut. Okay? And it really comes in handy. Okay? All right, so how do I get rid of the negative? How do I make the negative 4 a positive 4? What do I want to do with the fraction inside the flip it? So here's what we want to do, guys. Come on. Here's what we want to do. I want to flip this. Guys, everybody see what we just did? Just flipped it. And then that's going to make my negative 4 become positive 4. Now what do I do? What's my numerator going to be? 3 to the 4th over x to the 4th. Now, am I done? Not really. Go ahead and do 3 to the 4th in your calculator. 3 to the 4th. What'd you guys get? 81. Now, can you do with anything with the x to the 4th? No, there's your answer. And that's a lot easier than, getting everything negative and flipping it. And it's like, no, we don't want to do that. Can you guys try this? Do the shortcut. Oh, and by the way, the problems we're going to give you tonight, like this one, if we give you a quiz, you just can't plug this in your calc. You have to show how you got rid of the negative exponents. You can't just plug it in your calculator and spit out an answer. So what am I going to do with that? Get rid of that negative 3. Flip my what? Flip my fraction. And that becomes a positive 3 now. Now what do I write? Right? What do I write on top?
4 to the power 2.
4 to the 3rd over what, brother? 3 to the 3rd. So what do you got? What's over what?
64.
64 over what?
27.
There's my answer. Good job. Good job. Okay, a little more involved. Don't like that negative 2 exponent out there with my fraction, right? How are we going to get rid of it, Evan?
You flip
Flip what?
the negative 2 to the second power and the y.
So what do you want to write in the parentheses here?
Y to the 3rd over 2x to the second.
Nice job. And then I can make this what?
A positive.
Nice job. That's a huge step, guys, in solving this problem. Huge step. Now, Braden, okay, let's deal with, I'm going to talk to you in the denominator when we get down here. Okay, y to the 3rd raised to the 2nd. What do you do with the 3 and the 2, guys? Times it. So what do I got on top? Y to the, I'm done with that. Great. Here's where you're getting a little, there are 2 terms here. Don't think of it as one. So 2 is being squared, and so is x squared is being squared. Okay, so what's 2 becomes 2 to the 2nd, because there's a 1 here. 1 times 2 is 2. And then what's my x become? X to the what? X to the 4th. X to the 4th. Now, to simplify it, what's the one thing I have to do here? Ethan, what am I going to do here?
2 times 2 to the second.
Yeah, what is that?
4.
Guys, and for the love of humanity and all this on this green earth, don't write your exponent as big as the variables. All right? Sam Hill. Sam Hill. Okay, deal with one at a time. Let's flip this. 3 over 2 to the what? Good, second. Times, what do I write over here? 2n over 6m to the third. Geese. What? Okay, let's do one at a time here. Luca, what's 3 squared over 2 squared? What's that simplify to? Over, which is what? Give me the answer. What's 3 squared? Over 4. Okay? And this is kind of like this, right? There's a little more involved over here. Right on the top. And then we got 6 to the third over m to the third. So I'll stretch this down here. The first one was easy. 9 and a 4. Okay, what's 2 cubed, guys? It's 8. And then n to the third doesn't change. What's 6 cubed? How much? 216 m cubed. Okay, what do I do here to simplify? Multiply the numbers across, numerator, numerator. What's 9 times 8, guys? 4 times 216. 8 what? Now, you guys should be able to use the ABC button. Go 72 ABC 6 or 864 to reduce it. You guys agree it's 1 over 12? 112? Did everybody get that? So my answer is 1/12. Now, we don't have to write the 1 on top. It could have just been n cubed on top. Now, hang on to the homework we did last night. We'll go over that tomorrow also. And before here, what was that homework again? Did you put it on the website? Last night. We'll go over that tomorrow. Check it tomorrow, along with this.
No, I didn't have anything up there for tonight. Are we just doing the worksheet?
The worksheet.
Yeah.
Yeah. Do the best you can on that worksheet. Make sure you might want to check over the homework again tonight, or the homework you did last night if you thought you made a couple mistakes. I believe we're going to have a quiz over this next week, my friends. Tomorrow we're going to learn something new.